let's get right into it. Today, we're going to be decoding a BGP command that's, well, it's as powerful as it is confusing. It basically lets your network put on a secret identity. You know that feeling, right? You're scrolling through a router config, maybe one you didn't even write, and you hit a line that just stops you in your tracks. You just kind of stare at it and think, what in the world is that supposed to be doing? Well, for a whole lot of us in the networking world, this is that command. I mean, look at it. It's a total mouthful, isn't it? You've got local-as, then no-prepend, and replace-as all jammed together. It looks super intimidating. I get it. But hey, stick with me here. By the time we're done, we're going to unravel this whole mystery, and you'll know exactly what every single piece of this puzzle does. Okay, so let's start with the main event, the star of our show, the local-as command itself. So what is this whole disguise thing we're talking about? And, why would you ever even need one in the first place? So at its core, local-as is basically an identity swap for your router. It's pretty cool, actually. It lets your router, which lives in its real autonomous system, pretend to be part of a completely different AS. But here's the key. It only does this when it's talking to one specific neighbor. It's like putting on a digital mask. Only that one BGP peer you're talking to sees the new face. All right, let's actually see this little magic trick in action. In our setup, our router, let's call it R1, is really an AS 65,000. That's its true home. But when it talks to its neighbor, R2, it puts on its disguise and pretends to be an AS1. So think about it from R2's perspective. As far as it's concerned, AS 65,000 might as well not exist. It's just having a normal conversation with a router in AS1. A pretty convincing disguise, right? But of course, it's never that easy, is it? Especially in networking. The simplest solution is rarely the cleanest one. And it turns out using local-as all by itself creates let's call it an unwanted side effect. It's a subtle but really annoying problem that can seriously clutter up your BGP paths. So that begs the question, right? If it's so simple, why did that original command we looked at have all that extra stuff tacked on? What's the catch? There's always a catch. And here it is. By default, BGP doesn't actually replace your old identity. Nope, it just kind of slaps the new one on top, right in front, leaving your original AS number still hanging out in the path. I love this analogy. It's like showing up to a costume party with a cool mask on, but you forgot to take off your work name tag. It just creates this messy, confusing trail of AS numbers that doesn't look right. And this is what that messy trail actually looks like. When our neighbor gets a route from us, it sees both AS1, the mask, and AS 65,000, our real face. It's just not clean. And what's even crazier is that when we get routes from our neighbor, our own router adds the fake AS number to the path it just learned. It's adding clutter for no good reason. Okay, so we've established the default behavior is messy. We don't want a messy disguise, we're going for a perfect one, right? This is exactly where those extra keywords finally come into play. It's time to take control and clean this whole thing up. And lucky for us, we have two very specific tools for this job. You can think of it like a two-step cleaning process. First, we have No-Prepend. That's our tool for cleaning up the routes we receive. Then we have replace-as. And that's our tool for cleaning up the routes we send. So let's tackle the incoming stuff first. When we add the no-prepend keyword, we're basically telling our router, hey, listen, when you learn a route from this specific neighbor, just don't add my fake AS number to the path. Just leave it alone. It's a really simple, direct instruction. And the effect is instant. Just look at the difference. Before, the path we learned had our own fake AS number, AS1, stamped right on the front. It was just clutter. Now, after we add no-prepend, poof, it's gone. The path is clean. It only shows the path from our neighbor, which is exactly what we want. Okay, so our view of the world is now nice and tidy. That's great, but we're only halfway there. Our neighbor is still seeing that messy, cluttered path with both our real AS number and our fake one. We've got to fix the picture from their side of the fence. And this is where our second tool comes in, replace-as. And thankfully, it does exactly what the name suggests. For any routes we send out to our neighbor, it literally replaces our real AS, 65,000, with our fake one, AS1. So now our neighbor goes from seeing that confusing 165,000 path to just seeing a clean, simple one. Our real identity is now completely hidden from them. The disguise is working. So there we have it. We have both pieces of the puzzle.
We've got No-Prepend handling the incoming routes and Replace As handling the outgoing ones. Now let's put it all together and see what this complete, perfect transformation looks like.
And this is the really crucial takeaway here. When you use both of these keywords together, that's when the disguise becomes totally seamless. We stop adding junk to the paths we receive, and we fully, completely replace our identity on the paths we send. As far as this one neighbor is concerned, it's a complete identity takeover. And here is the big payoff. Remember where we started? With that default, messy, confusing path? But now, after putting it all together, we have the final, elegant solution. To our neighbor, and even in our own routing table, everything just looks clean. It's as if our router was always part of AS1. No more confusion, no more messy trails. All right, so let's do a quick recap of our Local-AS toolkit. It all starts with Local-AS itself. That's what puts on the disguise. But we have to remember its default behavior is messy. It leaves that ugly trail of AS numbers. So we bring in our cleaning crew. No-Prepend cleans up the routes we receive, and Replace As cleans up the routes we send. You use both together, and boom, you get a complete and totally seamless identity change. So I'll leave you with this thought. Now that you know how to cleanly and completely change your network's identity for a specific peer, what kind of powerful new possibilities does that unlock for you? I mean, this is a go-to tool for things like network migrations, handling company mergers, or dealing with really complex multi-provider setups. It's way more than just a neat configuration trick. It's a seriously powerful solution for a lot of tough real-world networking challenges.